Hello everyone. Before we move on to learning about data lookup using Pandas data frame, I want to capture the return value of the last data frame constructor function call into a variable called df. I'm going to do that by typing df equal to data frame constructor function call. We'll be using this df data frame variable to go through data lookup examples. Let's first recap data lookup using series data structure. We can look up a specific value within a series S using index label of X by mentioning s.loc of X, where we specify X within square brackets. Recall that LOC stands for location lookup. We can use the corresponding integer position of X to look up a value within S by saying s.iloc of X. Recall that ILOC stands for integer position location lookup. You could also look up a specific value by saying S of X. Pandas is going to look for an index X by default. If it cannot find an index X within the series S, it is going to fall back to looking for an integer position X within S. This particular lookup is ambiguous when it comes to series created from a Python list. You cannot use this lookup to mention negative integer position. That's going to throw an error. Instead, you'll have to explicitly use .iloc. In this particular example, I'm creating a series from a dictionary. The dictionary keys are player names. The corresponding values are player scores. We'll be using call1 series to review data lookup using series. When I say call1.loc of Bob, that's going to retrieve the value as 7 corresponding to the index Bob. Call1.iloc of 2 is going to return 8. That's because the value 6 has integer position of 0, value 7 has integer position of 1, value 8 has an integer position of 2 in this series. Call1 of Cindy is going to return the value as 8, which is the score corresponding to the index Cindy. Call1 of 1 is going to return the value of 7. That's because we are using the integer position as 1, which corresponds to that particular value. In this particular example, there is no conflict between index and integer position because we are creating the series using Python dictionary. Because of that reason, I can use call1 of -1 lookup to retrieve the value of 9, which is the very last value within the series. If we had created call1 series from a Python list, this particular lookup will throw an error. Let's learn about data frame lookups. I'm specifying the series lookups along with data frame lookups so that you can compare and contrast both. We have LOC and ILOC options using data frames as well. d.iloc of X is going to enable us to look up a specific row within the data frame D by mentioning the row integer position of X. Similarly, d.loc of X is going to enable us to retrieve a row by mentioning row index as X here. Observe that when we use LOC and ILOC for a series, the return value is going to be a single value, whereas when we use LOC and ILOC for a data frame, the return value is going to be a row series. Let's go through other options here. You would think that D of X is going to enable you to retrieve a row either based on row index of X or row integer position of X. That is not the case here. D of X will enable you to retrieve a specific column using the column index of X. This is something which you'll have to remember when it comes to Pandas data frames. How do we look up a specific value for a certain row and a specific column? We can use LOC and ILOC. Instead of just mentioning row index or row integer position, we need to mention column index and column integer position. Let's go through example lookups here. Let me go ahead and display the DF data frame. The first example that I want to show you is df.loc of A. Observe that I'm using the row index as A here. So that's going to return to us a series. Recall that internally pandas represents every row and column using the pandas series data structure. Because of that, when you look up a specific row, you're going to end up getting a series. We can confirm that by passing this particular lookup as an argument to the type built-in function call, and that's going to display pandas series here. Let's look at the details that we get for this series. The values of the series are going to be Alice and 6. Since we have two different data types of string and integer, the data type for this series is going to get displayed as object. You have the corresponding index as the column index. When you retrieve a row within a data frame, your return value series is going to contain index as column index. Similarly, when you retrieve a column within your data frame, your return value series is going to have index as row index. Both of those make intuitive sense. Let me talk about this name field over here. This particular field has a very bad name. I wish they had mentioned this as row index instead of name. That's what is getting displayed here. It just refers to the index corresponding to the row that you just looked up, which is going to be the string A here. Let me show you an example with ILOC. df.iloc of 1 is going to enable us to retrieve the values as Bob and 7. df.iloc of -1 is going to enable us to retrieve the last row values here as a row series, and you're going to get the values as Dan and 9. Let's go through a lookup operation for looking up a specific column. I can do that by saying df of column index. Let me go ahead and display df one more time. I'm going to show you how to retrieve the score column here. I'll have to say df of score. Observe that we are getting a series again. You're getting the values within the series as 6, 7, 8 and 9. The corresponding index are going to come from row index as A, B, C and D. Since all of the values within this series are of integer type, your data type is going to be int64, and the name field is going to be the column index here, which is going to be score. No matter whether you use integer position or an index to perform the lookup, the name field is always going to display the index. An example would be df.iloc of -1, which enabled us to look up the Dan row, but you're still getting the name as the row index D here. Let me show you how not to use the df of a certain column index lookup. If you say df of A, where A is a row index, that's going to throw key error. That's because no columns have an index of A within the data frame df. This is something you're going to have to remember. The df of lookup is going to be for looking up a specific column, so you'll have to use column index. Let me show you examples of retrieving specific values within the data frame. Let's say that we want to retrieve B's player name here. So I'll have to use df.loc, specify B as the row index first. That's going to enable us to retrieve the entire row series. If we want to specifically retrieve a column's value, we'll have to type in a comma and then mention the column index, which is going to be player name here, and that's going to enable us to retrieve the return value as string Bob. When I say df.loc of B and score, that's going to enable us to retrieve Bob's score over here. Let me show you an example with ILOC. I'll have to mention row integer position first. Let's say that we are interested in retrieving Dan's score here. I'll have to type integer position for row here as -1 because we are dealing with the last row. The score column is going to have the column integer position as 1. So that's going to be the second value that we are going to type here. This is going to enable us to get a return value of 9. If I want to get Dan string as the return value, I'll have to specify column integer position as 0, and that's going to enable us to retrieve Dan. Let's learn how to set values for a specific entry within the data frame. This is going to be very similar to how we set values within a series or within a Python dictionary. We can either use LOC or ILOC lookup to specifically refer to a certain row and columns value using row and column index or row and column integer position when it comes to ILOC, and then we can simply say equal to new value. Let's say that we want to set Bob's score to a value of 15. I'll have to type df.loc and mention row index as B for Bob, and then the column index is score, and then I'm going to say equal to 12. Let me go ahead and display df. Observe that we were able to update Bob's score to 12 here. Let me show you another example where we use plus equal to. Instead of saying equal to 12 for this particular Bob score setting, let's say that I want to increment the current value by 3. I'm going to type in plus equal to 3. That's going to enable us to update Bob's score by incrementing it with 3 here. Let's go through one example with ILOC. Let's say that I want to update Dan's score here by incrementing it with 2. I'm going to use row integer position as -1, and I'm going to use the column integer position as 1 for the score, and then I'll have to say plus equal to 2. That's going to enable us to update Dan's score by 11 here. Pandas is a very powerful data structure. It comes with a lot of functions available for you to readily use. I'm going to give you two such examples. This first question is asking how do we compute max score. Recall that you can retrieve the score column series by mentioning df of score. To compute the max score, you just need to type dot max open parenthesis close parenthesis, and that's going to return the max score is 15 here. To compute the mean of the score column, you can just replace max function call with mean function call, and that's going to enable you to get the return value as 10.0 float. Let's learn how to slice data frames. When you slice a specific list, you get a list. Recall that in general in Python, when you slice a specific data structure, you're going to get a similar data structure. So when you slice a data frame, you're going to end up getting a data frame. Since data frame is a two-dimensional structure, we'll have to deal with row slicing and column slicing. We are going to use similar syntax for LOC and ILOC when it comes to slicing. Let me show you a few examples here. Let's get started with ILOC. Slicing is easier to understand with integer positions. Let's say that I'm interested in getting a slice of the middle two rows over here. I'm going to do that by typing df.iloc, and the start of the row index slice is going to be 1, which is the index for this particular row, and the end of the row index slice is going to be 3. Recall that we need to use exclusive index when it comes to the end of the slice. So that's going to be the row slice. What should be the column slice here? Let's say that we want to slice just the score column. I can do that by typing 1 colon. Player name column has column integer position of 0. Score column has column integer position as 1 here. So if I say 1 colon, that's going to retrieve everything after the score column. Observe that you're getting a data frame here. The values within the data frame are going to be 15 and 8, which are the scores corresponding to the row index of B and C here. Let's say that you want to retrieve all the columns instead of just the score column. You can replace the column slicing here with just a colon, and that's going to enable you to retrieve both the player name column and the score column here. The cool thing about pandas is that you can use index also to perform slicing. Recall that you cannot do that when it comes to Python dictionary because dictionaries are not types of sequences. Let me show you an example. Instead of mentioning df.iloc, I'll have to mention df.loc because I will be using index. The only catch with index-based slicing is that index-based slicing does not use an exclusive end, it rather uses an inclusive end. So this is something which you'll have to remember when it comes to pandas data frames. I'll have to type the start of the slice as index B and end of the slice as index C here. Let's say that we are interested in retrieving all the columns for Bob and Cindy rows. Observe that you're getting the exact same data frame as before. Let's learn how to set values for a slice data frame. The syntax for that is going to be very simple and similar to what we went through for setting a specific value. You're going to mention the entire slice and then you're going to type equal to value over here. Let me go ahead and display data frame df. Let's use this last example. Let's say that we want to update the scores for Bob and Cindy. Instead of using colon as the column slice here, I'll have to mention score in order to look up just the score column. This is going to retrieve a series because I'm not mentioning a slice for the column, even though I'm mentioning a slice for the row. Since the column is for a single column, you're going to end up only getting a series here which has the values as 15 and 8. Now I can just say plus equal to 5 and let me go ahead and display df. Observe that we were able to update Bob and Cindy's score by incrementing it with a value of 5. Instead of using a slice to update values for specific rows, you could just mention a list of row indexes. Let's say that you want to update the values for Alice and Cindy. There is no way for you to write a slice which will just include Alice and Cindy. Recall that because pandas allows complex expressions within the lookup operations, you can look up by mentioning a list of row index. Let me give you an example here. I'm going to say df.loc, then I'm going to use a comma to specify row index and then the column index. For the row index, I'm going to mention a list of row index. I'll have to have the list items as A and C, and then I want to update the score columns value. I'm going to do that by typing in score over here. That's going to enable me to retrieve the corresponding score. Looks like I made some sort of a typo here. Because I mentioned small case c, I'm having a problem fixing that. Observe that we are getting a series where you have the values as 6 and 13 here. We are going to use this particular syntax to increment the existing value by an integer of 2. That's going to enable us to update Alice's score and Cindy's score by a value of 2 increment when compared to the previous display of df. I'll go ahead and wrap up this video here. In the next video, we are going to learn about the important concept of Boolean indexing.